Hello viewers, you're welcome to the second series on our discussion in indices. Okay, this second series, we're going to be solving more of problems on this second series. So if you've not watched the first series, I would suggest you go watch the first series because that will give you an insight on what we are going to be doing in this second series. The link will be right here on the screen, so you can just go and click the link, watch the first series, then before you can come over to this one and watch this one. So with that being said, let us go into today's question one step at a time. All right. So question one, I have question one. It says simplify 16 to the power 1 over 2. How do we simplify this initial expression? How? Now remember from our first series, we talk about when we have a to fractional power, fractional index as 1 over n. We say we're going to simplify this as the nth root of a. We will take this n as our root and this one as the power, right? So this is going to become nth root of a. So if you look at this case, you see the 1 is the power and here we have 2 as the root. So this is going to be like the square root of 16. But this 2 does not really matter because this is the same thing as square root. So what is square root of 16? The answer is 4. So let us go to question number 2. Question number 2 is says 16 to the power minus 3 over 2. Now the first thing here is to get rid of this negative guy. And the law which we talked about in the first series says when you have a to the negative power, to get rid of this negative guy, just have a fraction of 1 over a to that positive power now. So to do this guy is going to be like 1 over 16 to the power 3 over 2. You see, we've gotten rid of the negative guy, right? And now we can apply this other law. It says when you have a to the m over n, it's going to become the nth root of a all to the m power. This is your power and this is your root, right? We've talked about this in the first series, right? So from here, this is going to become 1 over this. This is the root and this is the power. So it becomes square root of 16 all to the power 3. I told you this guy is not necessary. Maybe subsequent examples, I will not be putting the 2 right here. So of course, this guy is the same thing as 1 over 4 to the power 3. Square root of 16 is 4, right? And that will give me 1 over 64 because 4 times 4 times 4, which is 4 to the power 3, is just 64. I hope you're enjoying this class. So let us go to the third example, question 3. Question 3 says we have question 3. It says 0.04 to the power 1 over 2. How do we simplify this one? The first thing you want to do is to convert these decimals to fraction. You know, 0.04 in fraction is 4 over, we have 2 decimal places here. After the decimal point, it's going to be 100. So 4 over 100 is the same as 0.04. Now let me show you other ways. If you have 1.5, it will be 1/5 over 10 because we have only 1 decimal place after the decimal point. So that is what it looks like, okay? That is how to convert decimals to fraction. So this guy is going to become 4 over 100 as we have seen, then to the power 1 over 2. Whenever you have the power 1 over 2, this is the same as square root, like we've talked about it earlier. So this is like the square root of 4 over 100. And you know the square root of 4 here is 2, and the square root of 100 here is 10. If you go further to simplify this fraction, you have 1 over 5 because we can divide this guy by 2 and divide here by 2. So the result will be 1 over 5. So let us go to the next question, question 4. Question number 4, it says when you have 64 over 125 to the power minus 1 over 3. How do we simplify this one? It's quite easy, and I talked to you about this in the first series. I say when you have a over b all to a negative power. To remove this negative power from here is quite different from the other ones we have seen. It's just interchanging the position of a and b. So we have now b over a all to the positive power. You see, interchanging their position. So to remove this negative guy from here, I'm going to interchange the position of this guy. So I have 125 over 64 all to that power, which is 1 over 3. And when you see 1 over 3, it's cube root, right? From the laws we've discussed earlier. So this is like cube root of 125 over 64. So from here, we know this, the cube root of 125, this is cube root of 125 over cube root of 64. Yes, you can go ahead and split it out this way. What's the cube root of 125? That is 5. What's the cube root of 64? That is 4. So that is how to get it. Then let me quickly explain what we mean by cube root. You know, when it says square root of 16, we say the answer is 4 because 4 times 4 will give you 16. When you say square root of 9, you say the answer is 3 because 3 times 3 will give you 9. Now, when we talk about square root, we're looking for two numbers that when you multiply them, you get this guy inside the root, which is called the radicand. Now, when we talk about cube root, let's say cube root of 8, for instance, the answer is 2 because 2 times 2 times 2 will give us 8. Now, for cube root, you're looking for 3 numbers because it is cube root. So for fourth root, you're looking for 4 numbers. For fifth root, 5 numbers. That is how the progression will continue, right? So that is how pretty much how it is. And that is how I got the cube root of 125. And also, that's how I got the cube root of 64. So let us go to the next question, which is question 4. All right, question 4 says, is it 4? Yeah, question 4, it says 36 over 169 all to the negative 1 over 2. This one is going to be a classwork for you. So I want you to solve it and put your answer in the comment section. All right, put your answer in the comment section. All right. All right, so let us go to the next question. Question 6. Question 5, rather. Question 5. I think I'm skipping my count, but that one doesn't really matter. Okay, so let's see how we can solve question 5. Question 5 is it says 8 upon 27 all to the power 2 over 3. Yeah, like we always talk about it, when you have a base to m over n, this is your root and this is the power. So this is the nth root of a all to the power n. So this is your root, this is your power. So it's going to be square root of 8 over 27. Sorry, cube root. This is 3. Sorry, this will be cube root. I mean to say cube root all to the power 2. Now, cube root of 8 is 2, and cube root of 27 is 3. Then all to the power 2. And this is 2 to the power 2 upon 3 to the power 2. 2 to the power 2 is just 4, and 3 to the power 2 is 9. So your answer is 4 over 9. Nothing can break down this fraction, so you leave your answer like this. Then let's go to question 6. So now we have question 6. It says 3a to the negative 1, and we have question 7. It says 3a to the negative 1. Yes, I just want to put them together because I can explain some things concerning these two guys. Now, for this one, the 3 and the a has this negative power. And for this one, the a only has a negative power 1. All right. So remember how we simplify a base when it has a negative power. Remember when you say a to the negative 1 m, it's 1 over a to the positive m. So this guy becomes 1 over 3a to that positive power 1. And you know, anything to the power 1 is the same as that same thing. So you have 3a, final answer. Now, for this case, the a is a guy that you have to change its power. So you have 3 times 1 over a to the first power. And that is the same as 3 times 1 over a. And of course, this is like 3 over 1. So 3 times 1 is 3, and a times 1 is a. So this is your answer for question 6 and question 7. Now let's go to question 8. I think question 8. Okay, after this, we'll take another example. So question 8 is saying square root of 125 to the power 2, then all to the power 1 over 3. How do you simplify this? The first thing, you start from the radicand, that is from the guys inside the root function. You remember the product law, it says a to the m all to the n. You have to multiply these two guys. So you have a to the m times n, which is mn. So I'm going to multiply these two guys. So I have square root of 125. Then I have 2 times this guy will give me 2/3, right? Right. Then, you know, when you have a to the 1/2, it is same as the square root of a. So this square root, I'm going to remove this square root from here. I put it in index form like this. So I have 125 to the power 2/3. Now all to the power. This guy is going to turn out to be 1/2, just like we see here. So you multiply these guys again. You see, this guy can actually cancel out this guy because it's multiplication, and now you're left with 125 to the power 1/3. And of course, this is the same thing as the cube root of 125. And the cube root of 125 is 5, because 5 times 5 times 5 will give us 125. So that's question 8. Let's do question 9. Question 9. And remember, all of these questions we've been solving, they are all under indicial expression. I made mention of this in our first series, indicial expression. And after this example, we are going to go into indicial equation. So let's solve this last one in this indicial expression. We have 49 to the power 1/2 times 3 to the power 0 times 4 to the power 3/2. How do we simplify this? Remember, when you have 1/2, this means square root of 49. And of course, any number to the power 0 is 1 times this whole guys become square root of 4 all to the power 3. We've talked about how we simplify questions like this. So what is square root of 49? Square root of 49 is 7 times 7 times 1 is 7, then times what is square root of 4? That's 2 to the power 3. And here we have 7 times 8, and that will give me 56, right? So that's the answer. 7 times 8 is 56. So this is the last question in indicial expression. Let us go over to indicial equation. Indicial equations. So let us take problems from that area and see how we can go about it. Now, the first question we have here, I'll call this one question 10, or let me start from question 1 again. Question 1. So this one is saying, simplify x1/2 is equal to 6. How do we find the value of x from this indicial expression? The reason why this is called indicial equation is the presence of this equation here, this equality sign here. So how do we find x? Now, the idea is to get rid of this power so that you can get the value of x. What can you multiply with 1/2 to make it 1? It's 2, right? So I'm going to take the square of both sides. So I'll take the square of both sides like this, square here, square here. It's possible so that these two can cancel out this guy. So I now have x equal to 6 squared, and that will give me x is equal to 36. So that is pretty much how these things work. Very simple, right? So let us go over to question 2 in this series. Now, what is question 2? It says a to the -2 is equal to 25. How do we simplify this one? I think I can do this problem in 2 different ways. Now, let's start with the first way. I have 25 here. Now, how can I remove -2 from a? If I decide to multiply this whole, expression by the power of -1/2, let us see how it goes. So I have a -2 here, then I multiply it by -1/2. Then I have here 25 to the power -1/2. Let's see how it works. Because this is minus times minus, we cancel out. Then these 2 can cancel out this 2 in the denominator. Then a will be free. So this is constructively how you can think of numbers that can eliminate these guys. And of course, this is you want to remove this negative power from here. You have 1/25 to the power 1/2. And that should give me a is equal to 1/square root of 25. And finally, that will give me 1/5. So that is the value of a. So let us think of it another way. I have a to the -2 equal to 25. How can I simplify this? Okay, let's say I want to take out this negative sign from here. So I have 1/a to the power 2 is equal to 25/1, right? This is how you can go about it. The next thing you want to do, you can cross and multiply. 1 times 1 is 1, and 25 multiply a squared, you have 25a squared. Now you divide everybody by 25 because you're looking for a So that this guy will be free. So now you have 1 over 25 is equal to a squared. Or I like to say a squared is equal to 1 over 25. Same thing, right? Now you can now take the square root of both sides to get rid of this guy. Square root of this guy, square root of this guy. The square cancels out the root. So a is equal to, what is square root of 1? Square root of 1 is 1. What is square root of 25? That's 5. So we still have 1 over 5. Anyone you feel comfortable with, go ahead and take it. That's your best. So next question. Question 3. Question 3. It says 3 to the power c minus 1 is equal to 81. This one is quite simple, very simple. Now, how do you solve this problem? Just transform 81 in the base of 3. You know, 81 is the same as 3 to the power 4, right? So then I have 3 to the power c minus 1 is equal to 3 to the power 4. So the idea of doing that is that the base will be the same. You can cancel out the base and you equate the exponent. So c minus 1 is equal to 4. Take minus 1 to this side, so you have c is equal to 4 plus 1. And definitely c is equal to 5. This one is quite easy and very straightforward. All right, I still have another problem here. So let us do this one. I have many of them here. So let's take another example. Question 4. This one, it says 5x is equal to 40x to the power minus 1 over 2. Wow, how do we solve this problem? What you just need to do here, take all the x to the x and all the y to the y. That's pretty much how you should do this one. Yeah, I can divide both sides by 5 here, divide here by 5. So this guy will cancel out this guy. So you have x is equal to 5 here is 1, 5 in 40 is 8. So I have 8x to the negative 1 over 2. Right? Okay, that's fine. Then I can decide to transform this negative guy from here. I can decide to transform this guy from here. What I mean is that, you know, when you have a negative exponent, you can write this guy as x is equal to 8 times 1 over x to the 1 over 2, right? To remove this negative power. It's possible, right? And all of these guys is the same thing as saying x is equal to 8 over x to the 1 over 2. This guy is over 1. So you cross multiply from here. When you cross multiply, so you have x times x to the 1 over 2 is equal to 8. 1 times 8 is 8. Now, this guy is having a power 1 here. So when applying the law of indices that says a to the m times a to the n, this whole guy becomes a to the m plus n. So I'm going to add up this power because they have the same base and they are multiplying. So I have x to the 1 plus half, and that is equal to 8, right? So next thing we do, we add this exponent. So if you add 1 and half, you get 3 over 2 equal to 8. Of course, like I always say, how do I remove 3 over 2 from 8? I mean from x. See what I'm going to do. Because I have 3 over 2 on x, I'll just multiply it by 2 over 3, the inverse of 3 over 2, so that these guys are going to cancel out. So remember, whatever you multiply here, you multiply here. So this 2 will cancel out this 2. 3 will cancel out 3. So x is now 3. And now you have 8 to the 2 over 3. And you know, when you have this guy, this is sitting as the cube root of 8 all to the second power. What is cube root of 8? That's 2 to the 2. And that 2 to the 2 is the same as 4. So definitely x must be equal to 4. This one is quite interesting, right? All right, so let's move on. If you're liking this video, please put down a good comment for more videos and subscribe. Now let's go to the next question. This one is question 6, right? It says 7 to the x is equal to 49. Now, this problem, I'm not going to solve this problem. I will leave it down for you. So put your answer in the comment section. Your answer must be equal to 2. If your answer is not 2, then that is wrong. So your answer is 2. So put down your answer. Oh, I already told you the answer already. Okay, yeah, so just go ahead and solve it. If you get 2, then that's correct. So let's go to the next question. Then we have another one. This one is question 7. It says 10 to the negative 3x is equal to 1 over 1,000. Wow, this is interesting. Now, how do we get the value of x here? Very simple. I would like to write these guys as now 10 to the negative 3x is equal to 1 over 1,000 is same as 10 raised to the power 3, right? Yeah, that's 10 times 10 times 10 will give me 1,000. That's the index form of this guy. So now remember, this old guy can also be written as 10 to the negative 3x is equal to 10 to the negative 3. What is 10 to the negative 3? You will tell me it is 1 over 10 to the positive 3 by taking out this negative sign from here. So this is the reverse. So that is what I did. This is just the reverse, taking this guy to this side. The whole reason why I'm doing this is that I want the base to be equal so I can cancel them out, and I equate the exponent. So I say minus 3x is equal to minus 3. Of course, divide both sides by minus 3, minus 3. These guys cancels out. So x must be equal to 1. Minus cancels out, 3 cancels out. So x must be equal to 1. So that is the answer to that question. Let's go to the question. Next question 8. Question 8. All right, so I'll be going deeper as we progress. So that is pretty much how it's going to look like. So question 8 now is kind of very interesting. This is a live question, okay? I'm just doing this real here. So I've not solved them, but they are quite easy. So let's go to question 8. 1 over 5 into 25 to the power n is equal to 25. Wow. So how do we solve this whole problem? How do we simplify? How do we get the value of n in this question? How do we get the value of n? Now you see we have 25, we have 25 here, we have 5. You just know 25 can be written in the base of 5 as 5 to the power 2. Very interesting. So that's the first thing I want to do here. There are a couple of ways to solve this problem, but we still end up with the same result. 1 over 5 into 5 to the power 2. Then because of the n, of course, it's going to be 5 to the power 2n, right? You understand? So here will be 5 to the power 2. Isn't it? Now, the next thing you want to do, I want to get rid of this fraction. So I want to multiply everybody by 5. I want to multiply everybody by 5. So if I multiply here by 5, I'll multiply here by 5. So that this 5, we cancel out this 5. So I have 5 to the 2n is equal to, this is like over 1. And you see they are multiplying, but so I can take one of the base and add their power. So I have 2 plus 1. And that will give me 5 to the 2n is equal to 5 to the 3. The base are the same, cancel them out. So therefore, 2n is equal to 3. And divide both sides by 2, n must be equal to 3 over 2. Is this clear? I know this one will be looking somehow to you, but that's very simple. Let's go to the next one. Question 9. All right. Let us solve question 9. This one is, it says 5 to the power 2 x minus 1 times 5 to the x plus 1 is equal to 0.04. This is question 9, right? How do we simplify these guys? Now, first thing I want to do here is, you know, these guys can distribute into them. So you have here to be 5, 2x minus 2. When you distribute with 2 into this bracket, so you have it to be times 5 to the x plus 1. Put them all in brackets like this. Equal to, this guy in decimal, in fraction will be 4 over 100. We've discussed that earlier. And if you further reduce this guy to be 1 over 25, right? 1 over 25. 4 here, 1, 4 in this guy should give me 25, isn't it? So now we'll move to this one. Now you see they are multiplying actually, and they have the same base. I'm going to take one of the base and I'll add their exponent. I'm going to add their exponent. So I have 2x minus 2 plus x plus 1. So that's what it looks like. So I'll add the exponent now. So I have 2x minus 2 plus x plus 1 equal to, and this old